Welcome to Spring LIB.
For this problem on the topic of alternating current, we are told that an AC generator provides EMF to a load in a remote factory over two transmission lines. Now, at the factory, we have a step-down transformer which reduces the voltage from its transmission value, which is VT, to a much lower value. The transmission line is a 0.3 ohm cable, and the power of the generator is 250 kilowatts. We're given VT to be 80 kilovolts, and we want to find the voltage decrease along the transmission line, the rate at which energy is dissipated in the line as thermal energy, PD, and then if VT is 8 kilovolts, we want to find again delta V and PD, and lastly, if VT is 0.8 kilovolts, what is the new voltage decrease, delta V and PD? Now, the RMS current in the cable, IRMS, is equal to the power P divided by VT, which is 250 times 10 to the power 3 watts divided by 80 times 10 to the power 3 volts, which gives us the current of 3.125 amperes. And therefore, the RMS voltage drop, delta V, is equal to the RMS current, IRMS, times the resistance R, which is 3.125 amperes times 2 for each cable times the resistance 0.3 ohms. And so this gives the voltage drop to be 1.9 volts. The rate of energy dissipation, PD, is equal to the RMS current squared times R, which is 3.125 amperes squared times 2 times 0.6 ohms, which is 5.9 watts. Now for part C, we have the RMS current to be the power 250 times 10 to the power 3 watts over VT, which is now 8 times 10 to the power 3 volts. And so the current is 31.25 amperes. And so delta V is equal to 31.25 multiplied by 0.6 ohms, which is 19 volts. So the potential drop is now greater. For part D, the rate at which energy is dissipated, PD, is now 31.25 amperes squared times the resistance of 0.6 ohms, which is 5.9 times 10 to the power 2 watts. For part E, we have the final RMS current, IRMS, to be again the power 250 times 10 to the power 3 watts divided by VT, which is now 0.8 times 10 to the power 3 volts, which gives the RMS current to be 312.5 amperes. So the potential drop delta V is 312.5 amperes times 0.6 ohms, which is 1.9 times 10 to the power 2 volts. And therefore, for the final power, or the rate at which energy is dissipated, PD, we get this to be the current 312.5 amperes squared times 0.6 ohms, which is 5.9 times 10 to the power 4 watts.